Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a very important problem involving application of First Law of Thermodynamics. First Law of Thermodynamics. What First Law of Thermodynamics says? Q is equal to, that is heat is equal to change in internal energy plus work done by the system. Because all heat is not converted to work. That is our standing from the first lecture itself. Please refer to my previous lectures on thermodynamics to understand. Q is equal to delta U plus W. Delta U is the change in internal energy. The internal energy at the particular position state at state 1 is something, and at state 2 the internal energy is something. The difference in internal energy, increase in the internal energy plus work done by the system is equal to heat. Q is equal to delta U plus W is the first law of thermodynamics. Here we will be doing a numerical using that, but this numerical involves change in pressure varies square to the a polynomial equation with respect to volume. P is equal to A plus bV². In this way, pressure is changing. And if the initial pressure of the system is 2 bar and the final pressure of the system is 5 bar and initial volume is 1 cubic meter and final volume is 3 cubic meter and change in internal energy is equal to 100 kilojoules, what is the heat? Heat transfer for the process is how much? Q is equal to how much? This is our question. Whereas pressure varies, it does not vary linearly, it varies in a polynomial way. P is equal to A plus bV². Now, let us try to solve this question. What are the parameters given? What is to be found out? Question is, what is heat transfer Q is equal to how much if pressure is equal to A plus bV² and the initial pressure is equal to 2 bar and final pressure is equal to 5 bar and initial volume is equal to 1 cubic meter and final volume is equal to 3 cubic meter and change in internal energy is equal to 100 kilojoules. This is what is given. We have to find Q, heat transfer in the process. Solution. You just see, P is equal to A plus bV² is given. We have to find out the values of A and B. First and foremost, our step is to find the values of A and B. Here, as per first law of thermodynamics, first law of thermodynamics says, first law of thermodynamics says, what it says? Just now I told you, Q is equal to delta U plus W. Please remember this. It's a very, very important equation in thermodynamics. Here delta U is given 100 kilojoules. Work done is not given, we have to find out. Then we will get the value of Q. Now, to get the work done, what is the equation? I have already explained you in the previous lectures. Please refer to them. W is equal to integral V1 to V2 P dV. Please refer to my previous lectures. This is another important equation in thermodynamics. One equation is Q is equal to delta U plus W. W is equal to V1 to V2 P dV. From this we will get the work done. From there we will get the heat. We wanted to find out heat. Now, to find our goal, first goal is to find W. Work done. How to find it? Here, pressure varies as, because we require P1 and P2, V1 and V2 we have. But pressure varies as, it's a process. P is equal to A plus bV². P1 is 2 bar. That is equal to, A is how much? We don't know. A plus B into V is, V1 is V1 square. That implies 2 is equal to A plus B into 1 cubic meter square. Sorry, B is equal to, volume is equal to first volume, V1 is 1 cubic meter, V2 is 3 cubic meter, we are right. That implies 2 is equal to A plus B. This is the first equation we have got for the process. Now, next, P2 is equal to how much? We should not make mistake here. P2 is equal to 5 bar. 5 bar. That is equal to A plus B into V2 square. That is equal to A is how much? We don't know. A plus B into 3 square. That implies A plus 9B is equal to 5. That is second. From this, first equation A plus B is equal to 2 and A plus 9B is equal to 5. By using our elementary algebraic knowledge, mathematics, we get the value of A as 1.625 and B as 0.375. We have put everything in bar only. We have not converted to kilopascal. We will get the work done in bar cubic meter. How to convert it into joules we know. I have already explained in the previous lecture. Now, A is this much, B is this much, P1 we know, P2 we know, and what is the work done? Work done is equal to integral V1 to V2 P dV. P is not independent. Let's depend on the process. That is V1 to V2. P is A plus bV² into dV. What is the value of A? Integral. V1 is how much? Volume 1. We have to do little bit of integration here. V1 is 1. V2 is 3. A is 1.625 because this is the process. 0.375 V square dV. That is equal to integral 1 to 3 integral sign is gone. We can remove, we can calculate something constant dV is equal to, that is V only. For this value, this will be 1.625 V. What are the limits? 1, 2, 3. Plus 0.375 V square is V cube by 3. Integral of dV is equal to V. Integral of V square is equal to V square dV is equal to V cube by 3. This you should be knowing by this time. Small integrals. You should know the small integrals and small differentiations while doing physics problems. Now, 1.625 V, 1 to 3, 0.375 V cube by 3, this is also 1 to 3. Therefore, work done is equal to 1.625 into 3 minus 1. Do you agree? Plus 0.375 by 3 into 3 cube minus 1 cube. That is equal to, work is equal to 1.625 into 2. 1.625 into 2 plus 0.375 divided by 3 into 9 minus 1 is 8. How much it will be? Just calculate. Without calculator we can do it. 1.625 into 2 is 3.25. Very simple calculation, little bit of arithmetics. 0.375 divided by 3 into 8, that is 1. Three cube is 27. Sorry, I made a mistake here. Not it is 8. It is 3 cube is 27. It will be 26. This is also 3.25. That implies work done by the system is equal to 6.50 bar cubic meter. Because we kept the volume in bar only. What is bar? Bar is equal to 100 kPa. bar cubic meter is equal to, this can be 100 K Newton per meter square. Pascal is Newton per meter square. Bar cubic meter is equal to 100 K into Newton per meter square into meter cube. That is equal to, bar cubic meter is equal to 100 kilojoules. Don't take too much of conversion each and every unit at the beginning itself. You can do the mathematics, it's easy to do it when bar is given. Do it in bars only and convert, you use this. 1 bar cubic meter is equal to 100 kilojoules. Because Newton meter is equal to joule. Please remember this. Physics can be half done, can be 50% of your problem is solved when you know the units perfectly. Now, what will be the value of W now? W is equal to, bar cubic meter is 100 kilojoules. 6.50 into 100 kilojoules. Why we have converted it to kilojoules? Because your internal energy is given in kilojoules. This is equal to 650 kilojoules. Now we got the value of W as 650 kilojoules and change in internal energy is equal to 100 kilojoules. Therefore, Q is equal to delta U plus 100, that is 100 kilojoules plus 650 kilojoules, that is equal to 750 kilojoules. The heat transfer in the process is 750 kilojoules. This is how we have to calculate and utilize the first law of thermodynamics principles, internal energy principles, and also calculation of work done from integral PDV equation, where P can be dependent on volume. With this, I want to conclude this lecture, and please pay attention to each and every concept here. Try to understand the concepts. I will do another numerical so that you will gain confidence as far as thermodynamics, first law of thermodynamics is concerned. We will do some more problem on isothermal also, if possible defining adiabatic process also in the next class. Best of luck to everybody. Thank you for listening to me. If there is a value addition because of this lecture to you, kindly hype this lecture, share this lecture, and subscribe to my channel Maths and Science by IITian. Thank you for listening to me. Thank you for viewing my lecture. Best of luck. Thank you.